What's up, my lovelies? It's Julia, and today we are going to be reviewing for our Algebra 2 Unit 2 test. And this test goes through all our quadratic equations, quadratic formula, discriminant, quadratic function, the different functions, the x value of vertex, axis of symmetry, and completing the square. And we are going to be going through all of this good stuff right in the next 5 minutes. This is going to be our little review packet. Let's do this. Okay, question number 1 says quad formula. So we need to show our work by using the quad formula. So I'd like to write our quad formula down, which is x equals negative b plus or minus the square root of 2, b squared minus 4ac all over 2a. And I'd also like to write out how this is an a, b, and c. Now all we just have to do is plug this into this equation. So x equals negative 3 plus or minus b squared, 3 squared minus 4 ac all over 2a, and that is 1. Remember, when you are inputting these values, always use as much parentheses as possible. It's a lot neater and it is mathematically accurate if you do it this way. So, now we're left with x equals negative 3 plus or minus. Plug in these numbers in your calculator. It's a lot easier, especially with all the sign changes. Please do not include the square root. Just do 3 squared minus 4 times 1 times the negative 5. You get 26. So x equals negative 3 plus or minus the square root of 26 over 2. Okay, so we're done. That's it. We just leave it this way. If it were a negative, if it was a negative under the radical, then we would have to simplify even more into a plus bi form. But since it's not, this is a very nice problem. We just leave it as so, like that. That is as simplified as it gets. Now for number 2, the square roots. 4x squared plus 3 equals 0. Okay. How do we do this? Well, the square roots, we're basically just taking the square root of the thing. Okay, we're going to bring this 3 to the other side, so subtract 3 both sides. We get 4x squared equals negative 3. Now we're going to do the square root of negative 4x squared, and then whenever we do something on this side, that means we have to do something on this side too. So we get the square root of negative 3. So the square root of 4x squared is going to be 2x, which equals I3. If you guys are having trouble on negative square roots and then all those i's, I will make another video. Just tell me in the comments below. And now all we have to do for the 2x, how do we get x alone? We have to divide both sides by 2, get rid of that. We have x equals I radical 3 over 2 plus or minus, do not forget that plus or minus. This is not in the simplest form of the a plus bi form, so we need to draw a little arrow and say that this is x equals the square root of 3 over 2, and always have your I in the middle and never forget your plus or minus. Now I'm going to skip question 3 because that's another quad formula. Let's try factoring, a little factoring review on number 4. Here we do, okay, let's do the AC method. We're going to label A, B, C. 2 times 12, we get 24. So what factors of 24 add up to 14? Just get rid of that negative for a second. Yeah, 12 and 2. So we're going to rewrite this equation, 2x. So if we're going to have negative 12 and negative 2, they sum up to negative 14. That's basically your AC method. So 2x squared minus 12x minus 2x plus 12. And do not forget to include your equals 0. We're not just simplifying No, we're actually solving for x, okay? So we have 12 equals 0. So now we're going to factor these two. The greatest common factor of these two is going to be 2x. So times x minus 6. And then we're going to take that negative, bring that right over here, and the greatest common factor of here is 2. So we're going to have x minus 6, because negative 2 times negative 6 equals a positive 12. And we can kind of like check if we're going in the right direction, because these two are equal. So now we're going to have 2x minus 2 times x minus 6 equals 0. Do not forget your equals 0. So now we're going to solve each one individually. 2x minus 2 equals 0. We're going to add 2 on both sides, plus 2. 2x equals 2 divided by 2 both sides. We get x equals 1. Now we have to do x minus 6 equals 0. So x minus 6 equals 0, plus 6, x equals 6. Now we're going to rewrite this so it's all nice in the mathematical way. To x equals, with our, let's redo this. This looks ugly. X equals, with our beautiful French curly brackets, 1 and 6. And this is how you mathematically write it when you have like your x values known. And for the square roots, let's do another practice with the square roots again. For number 7, we are going to subtract 21 on both sides, minus 21. X plus 8 squared equals negative 18. And we're going to take the square root on both sides. We have x plus 8. We get rid of all that good stuff. And what is the square root of negative 18? Well, of course, we're going to have our eyes together. So let's keep our eyes on the prize. So what's a perfect square that is multiplied by another value that gives us 18? If you say 9 and 2, then you're correct. So we're going to have 3i outside and then 2 under the radical. Don't forget your plus or minus, so we're going to subtract 8 by both sides, minus 8, x equals negative 8 plus or minus 3i, i2. Since this is an a plus bi form, we are good to go. Now for number 8, we're going to do a method of your choice. 5x squared minus 82x equals 17. Okay, so right there, like, what do you think that you should do? If you said right off the bat quad formula, then you're pretty good, because in quad formula you can literally do anything. I'm kind of too lazy to do that there, because I assume that you guys already know how to do the quad formula. We're going to go on to the next page. Now we are going to be completing the square. I don't know why, but according to our teacher, she says that the New York State will enforce your hand upon this, so we definitely need to practice this, especially since this is going to end up on the regions. So for completing the square, we have 2x squared minus 12x plus 20 equals 0. Okay, so what is the greatest common factor of this thing? I know we're not using greatest common factor, but what number does all of these numbers have in common? Well, if you said 2, then you are correct. So divided by 2, divided by 2, divided by 2, and divide by 2 on the 0 side, because that's how you make it mathematically relevant. So 2 divided by 2, we are stuck with x squared minus 6x plus 10 equals 0. Okay, so now we have x squared minus 6x plus 10 equals 0. We're going to take this 10 and subtract on both sides, negative 10 minus 10, and we have x squared, oh I can't see that, x squared minus 6x plus a blank equals negative 10 plus blank. So what goes in the blanks? It's going to be our b divided by 2 squared. So negative 6 divided by 2 equals negative 3. I square that, and then we're just going to duplicate this and drag it over here, negative 3 squared. This is very simple. All we just have to do is x minus 3 squared. Just take these two, drag it down here, equals, so what, negative 10 plus negative 3 squared. So negative 3 squared equals positive 9. So negative 10 plus 9 gives us a negative 1. Square root both sides. We get x minus 3 equals the square root of negative 1. With negative 1, we can just replace that with I. So x minus 3 equals I plus or minus I plus 3. X equals positive 3 plus or minus I. There we go. This is in our a plus bi form. That is correct. So for more completing the square practice. Okay. So what's the greatest common factor for all of these? Negative 3. It's negative because we're going to be taking on the sign of this coefficient. So divide by negative 3 on both sides. Don't forget to include that 0. We get a positive x squared plus, minus 4x plus 2 equals 0. We're going to subtract 2 on both sides. Minus 2, x squared minus 4x plus blank equals negative 2 plus blank. So what goes in these blanks is going to be, here, I'll show you a visual representation, b over 2 squared. So, negative 4 divided by 2 is going to be negative 2 squared. We're just going to write that out, negative 2 squared. Then we're going to duplicate that, bring it on over here, negative 2 squared. So we're just going to do x minus 2 squared equals, what's negative 2 plus negative 2 squared? Negative 2 squared is going to give us a positive 4, so 4 minus 2 is going to give us positive 2. Take the square root of both sides. I'm going to make a little arrow. We're going to have x minus 2 equals the square root of 2. Plus or minus. Do not forget about your plus or minus. So we're going to add 2 on both sides. Plus 2. We get x equals positive 2 plus or minus the square root of 2. There you go. So for number 11, here's our question. The discriminant of a quadratic equation whose graph is entirely above the x-axis would have to be, so again, what is the discriminant? Our discriminant is going to be b squared minus 4ac. I do remember that our teacher said that if the discriminant is a negative, resulting in an imaginary number, it is going to be above the x-axis. And since this is saying entirely above the x-axis, it would have to be negative. Now for number 12, it says, for what integer value of a would ax squared minus 6x plus 8 equal 0 produce imaginary roots? Okay, so we're just going to be plugging in the discriminant if we look according up here. Actually, you know what, I'm going to teach you guys a really, we don't have to do any of that little crap. Just go on your calculator, and whenever, if it says that, okay, you know what, I'll just explain to you. So, to solve for number 12, instead of, since this is a multiple choice, you can easily go on your calculator and figure this out. How you can figure this out is, you can go on each graph, and you can plug it in. And the graph will tell you that if it is a negative number, that it won't graph it at all, period. Because this RTN inspires CX, it's not advanced enough to calculate imaginary versus real numbers. So, just try that out there, and I'll give you some time so you guys can try it out on your calculator, and whenever it says that, oh no, you can't do it, that's going to be your answer. I'm going to try it out on my calculator. If that's your answer, I'll just show you how to do it. So we have ax squared, let's use negative 1. Negative 1 squared minus 6x plus 8. Okay, so obviously that makes something, so I'm going to cross that negative 1 out. That's not one of the answers. I'm going to go to menu, do graph entry, function, and then we can replace it with 0, so 0. x squared minus 6x plus 8. Okay, we get something out of that. That's not going to be one of them. And we're going to plug in, let's go menu, number 3, number 1. We're going to plug in 2x squared minus 6x plus 8. Oh, there we go. Okay. Sorry about what I was saying before. It actually will calculate it, but as we said before, if it's above the x-axis, it's going to be a negative that will produce an imaginary root. That's like what we've been repeating before. So it is going to be 2. And for number 1, we're going to try number 1 out just for kicks. X squared minus 6x plus 8. Where is it? Oh, I didn't do it. Let me try it again. X squared minus 6x plus 8. And since this is touching the x-axis, it's well, by looking at that, obviously you get 2 solutions, so it's gonna be 2, since it is above the x-axis. Okay, so what number 12? I was explaining that a little bit, definitely. I'm sorry. For 13, a parabola whose graph goes to the x-axis one time would have roots that are 1. Real, rational, and unequal, real, rational, and real, irrational, and unequal, real, rational, and equal, or 4 imaginary. So right off the bat, for imaginary, we know it's going to be above the x-axis, and it says that goes through the x-axis. So number 4, it's going to be out. We don't need 4. For number 1, real, rational, and unequal. Well, that's going to. Well, if we're saying it's only going to be one time. These two, they're going to hit the x-axis twice, because if we look at an example, it's still going to do it. Now we're left with real, rational, and equal. If we think back to our notes earlier, it says that the equal is going to equal to 0. And we know that if it's equal to 0, it's only going to hit the x-axis once. So we do number 3. For 14, positive values of m will the equation 4x squared plus mx plus 9 equal 0 have roots that are real, rational, and equal. Okay, if we keep this in mind, all we just have to do is plug and chug this into a calculator on the graph section. If they are real, rational, and equal. Oh, okay, I'm sorry. We can just use a discriminant and plug and chug for that. So our discriminant, I'm just going to label A, B, C. Our discriminant is b squared minus 4ac. So we'll use 4 squared minus 4a, which is 4 times 9. I'm going to just plug that into my calculator and see if it gives me a whole number or an irrational number, which either consists of decimals or fractions. And let's pray this is right. 4 squared minus 4 times 4 times 9. Nope, it says it is non-real, so this might be an imaginary number. So let's just cross that number 4 choice out. So now we're going to try 3. Square root of 3 squared minus 4 times 4 times 9. Oh, it says error, non-real calculations. You know that this is going to be imaginary. Just like my friends. Okay. Now we're going to try this again. Keep plugging and chugging. For 9. 9 squared minus 4 times 4 times 9. Oh, it says non-real calculation. So we're just going to cross that out. So we're going to pray that 12 is right, because we don't know if it's right or wrong. We always need to check it. Okay. So the square root, 12 squared minus 4 times 9. Yay, we get a positive, well, it's not positive or negative, it's neutral, 0, and that 0 is real, so 12 will be the correct answer for that. Okay, number 15, the discriminant of a quadratic equation is 24. The roots are real, rational, and unequal. 2, real, irrational, and unequal. 3, real, rational, and equal, and 4, imaginary. Okay, so right off the bat, if we know that the discriminant is 24, we're just going to write the square root of 24. How do we know if it's imaginary or not? Do we see any i's or negatives under the radical? No, I don't think so. So we're just going to cross that little thing out. Real, rational, and equal. When it says real, rational, and equal, the discriminant has to equal to 0. Do I see any zeros anywhere? No, I do not. So we're going to cross that little thing out too. For number 1, it says real, rational, and unequal. The thing about the rationality is this a perfect square? Are there any like perfect square numbers that, okay, is this a perfect square? If you say no, then you are correct. If it's real, irrational, and unequal, you know, we can prove this with our calculator. If we just hit that little square root button, here we go, and we put 24 and put that in there, we get a nasty negative number, if you can see that. Ooh, look at that. And we don't, sorry, I said negative, it's a positive number, but it's nasty with all those decimals, so it's going to be number 2. Number 16, for which value of k will the roots of the equation 2x squared minus 5x plus k equals 0 be imaginary? Okay, this is pretty simple. All we just have to do is plug this into our calculator. If it is above the x-axis, then we know the culprit is going to be imaginary. So we're going to plug and chug this in our calculators. 2x squared minus 5x plus 4. We're going to start off with 4. Oh, I see it. Bada bing, bada boom. It's above the x-axis. We're just going to circle that thing. The reason why I like doing the end ones first is that statistically, I don't know if this is right or not, but it seems to work for me. A lot of like the right answers seem to be at the end and not A, B. It's always like C or D. For 17, find the discriminant for each equation and use it to describe the nature of the roots. Here are the following options. 3x squared plus 7 equals negative 2x. Okay. So bring the negative 2x to the other side. We have 3x. 3x squared plus 2x plus 7 equals 0. I'm going to label my A, B, and C. Oh, it's out of focus. Okay, so focus. Okay. So we have b squared minus 4ac. We have 2 squared minus 4 times 3 times 7, which is c. And we're going to just plug and chug this thing to our calculator, so it will help determine what this thing is. Okay. 2 squared minus 4 times 3 times 7. Whoa, it says non-real. If it's not real, that means it's imaginary. So all you just have to do is this is going to be 4, which is imaginary. Okay, so now for 10 minus 3x equals x squared. I want the x squared to be positive. I don't know why, I just like it positive. So let's just bring all this stuff over here. We're going to have x squared plus 3x minus 10. And that's going to equal 0. So let's plug this into our calculators. Oh, wait, no, I'm sorry. Okay, I'm going too fast. It has to be a discriminant, so we have a, b, and c. We have b squared, which is 3 squared, minus 4 times a, which is 1, times c, which is negative 10. Plug this into our calculators. 3 squared minus 4 times 1 times negative 10. We get a really nice number, which is 7. I really like that. So, if we get a really nice 7, well, whole number 7, obviously it's not going to be 3, because if it's equal, our discriminant would equal to 0, and 7 is not equal to 0, so it's not going to be 3. If it is 2 real irrational, which is unequal, you'd get a nasty decimal number, or a fraction. So it's not going to be 2. And 1, it says 2 real rational unequal. It's going to be 1. Question number 18. Use a discriminant to match each function with its graph. Do not graph in your calculator. Okay, so what is the discriminant for f of x equals ax minus 4x plus 2? Discriminant, remember, is b squared minus 4ac, so b squared is going to be negative 4 squared minus 4ac, which is 2. And with this, we get, let's put that into our calculator, not the graphing calculator portion, just your regular calculator portion. We have negative 4 squared minus 4 times 1 times 2. We get 2.52, sorry, okay, I can't read this, 2.8284, okay. So we get a whole number, it's 2, and it's irrational, so where does this fit? But before I'd like to pick which one I know it is, for this one, we obviously know this is going to have to be an imaginary number under the radical. For this, it's going to have to be irrational or rational, and for this, it has to either be equal to 0. And since it's neither for this number, it's going to be 2.82, it's not imaginary, and it's not equal to 0, so it's going to be 2. So A is going to be equal to 2. So for B, we have x squared minus 4x plus 4. I'm going to write that down here. B squared, which is negative 4 squared minus 4 times A times 4. Plug that into our calculators. We have negative 4 squared minus 4 times 4. Okay, so this equals the discriminant. It's going to equal to 0. I'm going to show an arrow to represent that the radical is 0. Radical, it is 0. Okay, so which of these, I don't know if you guys remember what I said, but which of these graphs tells us that it's going to equal 0? So when 0 is under the radical, or when 0 is a discriminant, this means it's going to touch the axis only once. So which of these graphs touch the axis once? Since 2 is out of the question, we already solved 2. For 1, it's above the x-axis. It doesn't touch the x-axis at all. So we're going to go to 3. And just to save time, because this video is like ending up like 30 minutes long, for C, it's going to be number 1. We're just going to use the process of elimination. So now for number B. Sorry, I meant letter B. When will the pumpkin hit the ground? The hint is height equals 0. So, if we refer back to this equation, h of t equals negative 16t squared plus 215t equals 40. The equation for that is literally the same as h equals negative 16t squared and all that, the rest of that good stuff. So, I'm going to rewrite that again. But if we know that h equals 0, because hitting the ground is going to be going back to 0 feet, all we're just going to have to do is replace that h with 0 and then transfer all that to over here. So 0 equals negative 16t squared plus 215t plus 40. So how are we going to solve this? Could we use the quadratic formula? Could we use the square roots method or factor? Obviously, if we're dealing with this, we're gonna want to use the quadratic formula, because all we can just do is plug that baby into our calculator, and then when we get the answer, we just round it to the nearest hundredth. This is going to be the only time when we're ever going to use our calculator is these awesome word problems. Okay, I don't know about awesome, but you know what, let's do this. Solve this. Our quadratic formula, I'm going to write off in the side, is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. We have a, b, c. X equals negative b, negative 215, plus or minus b squared minus 4 AC all over 2A, which is negative 16. And just plug that into your calculator. Remember to do 2 times because you're gonna add the negative 215 to this, and then you're gonna subtract that of negative 215. We get negative 0.18, and this is supposed to be in seconds because it's asking when. So off the bat, I know this is going to be a reject because it's a negative. So now we're gonna try subtracting it. So negative 215 minus the radical . Oh, whoops, I did it wrong. Okay, we get a positive 13.62 seconds. It is rounded to the nearest hundredth, so we're good. It's asking 1, so it's going to seconds. That's what we're solving for. And we're just going to circle this, and that's going to be our answer. So what is a reasonable domain inputs for the function? Okay, we can basically just go on our calculator, go in the graph section, plug in the h of t equation. Remember, replace your t value with x because it's just less confusing for the calculator. So negative 16x squared plus 215x plus 40. And you see that it is a very wide parabola. We're going to go to number 4, Windows Zoom, and then you're going to zoom out. Now that you've zoomed out, we're just going to go back to menu. We're going to do number 6, Analyze Graph, and we're going to figure out our zeros because that's what it's asking, like what is the domain for the function. We get negative 0.18. Remember, oh, I'm sorry, it's only going to be the first quadrant. So the reasonable domain, there's no such thing as negative seconds. So it's going to start off as 0 and to 13.62. You actually don't really have to go back to your calculator. I don't know why I did that. So determine the number, determine the time, number of seconds after blast off, when the pumpkin will reach 300 feet in the air. Okay. So we're talking about height. We're going to do our 300 equals negative 16t squared plus 215t plus 40. We're going to subtract 300 both sides. And we're left with 0 equals negative 16t squared plus 215t. And what is negative 300 plus 40? We get negative 260. Apply that quadratic formula and we get x equals 1.34 seconds. Now for E. What time does the pumpkin reach its maximum height? What is the maximum height of the pumpkin? We're going to use our little vertex formula, which is x equals negative b all over 2a. And if we refer back to the equation, our negative b, what's our negative b? Okay, and negative b is going to be negative 215 all over 2a, which is 2 times negative 16. Negative 215 divided by negative 32. Whoop. We get a positive 6.72. Remember, it says round to the nearest hundredth for all these mathematical calculations. So 6.72 seconds. And what is the maximum height of the pumpkin? So if we go refer back to our equation again, if we do h of t, or h of 6.72, equals negative 16 times 6.72 squared plus 215 times 6.72 minus 260. Here we have h of 6.72. We get we get 762.27 if you guys just plug and chug all that. And I'm gonna never forget your units when you're solving for the answer, and it's gonna be feet. So it's just find the average rate of change of the height of pumpkin from 1 second to 3 seconds. When it says average rate of change, what is that saying? It's asking you to find the slope. So I'm going to write slope, average rate of change. We got that as our slope. So let's go back to our graph because we're kind of lazy. We don't want to plug all that in. We're just going to type in our equation again of negative 16x squared plus 215x plus 40. Then once you get this, once you get that parabola, you're going to go to Control T, which is your table, and you have 1, which equals 239, and we have 3, which is 551. Three, which is 541. And our equation is y2 minus y1 over x2 minus x1. That's going to give us our slope. I'm going to label x1, y1, x2, y2. 541 minus 239 over 3 minus 1, which equals 2. 541 minus 239. Which is 302. 302 divided by 2, you get 151. That is going to be our average rate of change. When it says average rate of change, this is going to be our height on the top, which is feet, and the bottom is going to be our time, which is seconds. It's going to be 151 feet per second. We're solving for our velocity. And there you guys have it. This is your review.